Now for our next part, we need to find the net magnetic field at point P, which means we have to add B1 and B2 as vectors. So let's see if we can write B1 and B2 as vectors. First off, let's try and find the components of B1. Let's find the components of B2. Then to find the net field, we'll just add up those components. Looking at our diagram, we can find this angle right here. Let's call that angle alpha. So tan of alpha would be the opposite over the adjacent. So that angle alpha would be the inverse tan of 0.1 over 0.15. So if we get our calculator out, we can find that angle. So we do the inverse tan of 0.1 divided by 0.15. That gives us an angle of 33.7 degrees. This angle, theta, since R and B are perpendicular, alpha plus theta must be 90 degrees. So theta is 90 degrees minus alpha. So 90 degrees minus that guy gives us 56.3 degrees. So now we can write B1 as a vector. So B1, and if it helps, we can even draw it again down here. So there's B1. It's at an angle of 56.3 below the negative x-axis. So it has an x component that points this way, B1x, and it has a y component that points this way, B1y. So now we can write that guy as a vector. So B1 is equal to B1 in the x direction plus B1 in the y direction. B1 in the x direction is minus because it points left, B1 times cosine theta. B1 in the y direction is negative because it points down, B1 times sine theta because the y component is opposite our angle, J. So we can find out what those two components are. So B1 times cosine theta is 1.39 times cosine 56.3. So in the x direction, we have minus 0.755 times 10 to the minus 6 teslas. That's the x part. In the y part, we have B1, 1.39, times sine of our angle, times sine 56.3. So minus 1.16 times 10 to the minus 6 teslas in the j direction. So there's our vector B1. Vector B2 is even easier. B2 doesn't have an x direction, so that x component is 0. The y component points down, so it's negative, and it's the whole thing, minus 2.33 times 10 to the minus 6 teslas. So our net magnetic field is B1 plus B2. So we add the x's together. So the only x we have is B1x, so minus 0.755 times 10 to the minus 6 teslas in the I direction. Then we add the y's together. So in adding the y's together, so B net x equals B1x plus B2x, B net y equals B1y plus B2y. So adding those two y's together, we get minus 1.16 plus a negative 2.33 to get minus 3.49 times 10 to the minus 6 teslas, and that's the y part. So there's our net magnetic field vector. In the next part, we're going to think about forces.